question is, let f of x is equal to x square minus 2x plus 2 be a continuous function defined on x belongs to closed interval 1 to 3. The point x at which the tangent of f of x becomes parallel to the straight line joining f1 and f3 is, let's draw the function f of x to understand this problem in more details. Now suppose this is the graph of function f of x, that is f of x is given by x square minus 2x plus 2, and the domain of this function f of x is given as from 1 to 3. So this is the domain in which the function f of x is defined. So the function given to us is y is equal to f of x, and it is defined in closed interval 1 to 3. So corresponding y value will be f of 1, and this right here it will be f of 3. Now let's say this point here is A and this point is point B. Now if we draw a line from A to B, it will have some slope, let's say m. Now according to the problem, we need to find a point between 1 to 3 somewhere, some value of x, suppose let's say here x, for which if we draw the slope at this point, that should be parallel to AB. That slope must be parallel to the slope of AB, something like this. Now let's say this point be x naught. So according to the problem, the slope f dash of x naught must be equal to the slope m. Therefore, according to the problem, slope, let's write like this, slope AB should be equal to slope at x naught, so f x naught. So we need to find this point x naught here. So this problem, if you observe closely, is an example of Lagrange's mean value theorem. So let's understand what Lagrange's mean value theorem says. So according to Lagrange's mean value theorem, if there is a function f that is defined in the domain a closed interval a to b and has the range all real numbers, and if it is a continuous function and it is differentiable on the open interval a to b, then there must exist some c belongs to a to b. So in between a to b, open interval a to b, there must exist a c such that the slope at point c can be written as the value of function at b minus the value of function at a divided by b minus a. And this LMVT, the Lagrange's mean value theorem, can very easily be proved using the Rolle's theorem. So in our problem, that c is x naught, a is 1 and b is 3. So we need to find the value of c, that is x naught. At this moment, you can pause the video, and using the given data and the concept explained above, you can try to find the solution by yourself. Of course, at any point, you can resume the video. Now let's continue with our solution. Now if we use the LMVT, that is Lagrange's mean value theorem, we can write. So let's go back to the graph that we have drawn earlier. Here we need to find this x naught value. The initial, that a is 1 and b is 3. So we can find, since the function is given to us, we can find f of 3 and f of 1, right? So let's go back. So function given to us is f of x is x square minus 2x plus 2. F of 1 will be equal to 1 square minus 2 into 1 plus 2, that is equal to 1. And f of 3 will be equal to 3 square minus 2 into 3 plus 2, that is equal to 5. So using LMVT, we can write f dash of x naught is equal to f of 3 minus f of 1 divided by 3 minus 1. So f dash of x naught is, so let's differentiate this function. We get 2x minus 2, and this is at x naught, so let's write x naught here, is equal to f of 3 we just calculated 5 minus f of 1 is 1 divided by 3 minus 1, that is 2. 4 by 2, that is 2. Now from here we can calculate x naught. So x naught will be equal to 2 plus 2 divided by 2, that is again equal to 2. Therefore x naught is equal to 2 is the point in between 1 and 3 where the slope of this function is equal to slope of this straight line AB. Okay, so this point x naught, we can say this is at 2. Let's match with the options. So we can see here option C is the correct answer. To get detailed information on mean value theorems, you can refer to the NPTEL course of Engineering Mathematics 1 by Professor Jitendra Kumar of the Department of Mathematics, IIT Kharagpur.